Hello Year 11 and welcome to our first video for our fifth topic. We are looking at analysing data and get comfortable because I think this first one is going to be a little long. So to begin with, we are looking at the mean, the median, the mode, and of course you're pretty familiar with these things, you've learned them before. The mean is what we call the average, and we can calculate that as the sum of the scores divided by the number of scores. Okay, we add all the scores together divided by the number. All good? That's good for continuous data, right? Remember, that's things that are measured. Pretty good for discrete data too, I guess, things that are counted. You can't use it for categorical data, for nominal or ordinal data, right? It's no good for that. Now, when we have skewed data, and we'll learn more about that in another video, but data that is irregular in some way, that has some sort of imbalance to it, or data with significant outliers, that is like some really big or really small scores, fits into that same category really as a sort of an imbalance to the data, then the mean can become a bit misleading. Now, we avoid that misleading aspect of the mean by using this thing called the median, which is the middle of a data set. Right, now, it might be the middle score where I've got an odd number of scores, or it might be halfway between the two scores closest to the middle when I have an even number of scores. Okay. So the median is particularly good when we have this imbalanced data, skewed data, or data with outliers in it. Okay, so the median is good for that. The mode is the most common score, the score with the highest frequency. Now, the mode is the only real tool we have for analysing categorical data, numerical and ordinal, not numerical, nominal and ordinal data. Okay, so the mode is good for that. We can use it for other things. We tend not to very much, honestly, because it doesn't really tell us too much, and often you can just sort of see it at a glance anyway. There's not much analysis involved in it. So here we go. Here's a question. Calculate the mean, the median, the mode of these scores. Now, to get the mean, I add these scores together, and the sum of these scores 4, I think, unless I've got that wrong. So if I add all of those together, I'm going to say the mean equals 74 over the number of scores there, and I think there's 10, gives me, oops, the mean looks like this. Therefore, the mean is 7.4. Okay, and that looks about right. Now, to calculate the median, right, I find the middle, but be careful. Our scores need to be arranged in order for this to happen. So let's rewrite them in order. I think if we say 5, 5, right, there's another 5 there. And then a 6. We've got any more 6s? No. Any 7s? No. Then we've got some 8s. Right, I think that's all of them. A 9, a couple of 10s. Righto, and there, do I have 1, 2, 3, 4, 5, 6, 7, 8, 9? I've got 10 scores there. I hope that's right. To find the median, right, I'm going to separate it into a top half and a bottom half, right? The bottom half, each half is going to have 5 scores in it. 1, 2, 3, 4, 5. So here we go. There's my bottom half, there's my top half. So the median then is 8. Right, it's neatly halfway between 8 and 8 is 8. The mode, well, in fact, what I have here is bimodal data. See, I have 3 5s and I have 3 8s. So we have 2 modes, 5 and 8. Okay, that wasn't too hard. Now, this is a bit more challenging, and this pops up in tests every now and again, so I thought I'd put it here in the notes. I want a set of 5 numbers that has a mode of 4, median of 5, and a mean of 6. So, how I like to attack these ones is to indicate, there's my 5 scores, right? I've got to fill up those 5 spots. Now, a mode of 4 means that I'm going to have, well, at least 2. Oh, sorry, let's say the median first is 5, so I can put that in. That's a good way to go. Right? Now, the other scores have to be, I need 2 scores less than 5 and 2 greater than 5. It could be equal, I suppose. But the mode is 4. So if I fill up both of these with 4s, okay, now I'm pretty happy that I've got a median of 5, perhaps, as long as I've got bigger numbers here, and a mode of 4. As long as these 2 numbers are different, then my mode will be 4. Now, a mean of 6 means that the 5 numbers together have to have a mean of 6. Means that when I add them together and divide it by 5, I get 6. Means when I add them together, it must be 30, right? 5 lots of 6. So far here, I have 13. That means my other two numbers must add up to 17, and I think an 8 and a 9 will do the job just fine. It's a 7 and a 10, or a 6 and an 11. It would be fine. I wouldn't want to go with a 5 and a 12, because then my mode isn't really 4. I would have a mode of 4 and 5. Okay, all good? That's a fun one to do. Moving along now, frequency table or frequency distribution table is what I'm most accustomed to calling them. We can use these things in various iterations and various forms to help us calculate mean, median, and mode, and perhaps some other things other times as well. These are mostly a relic of the days before we had calculators. With statistic mode, that would do lots of these things easily for us, but nonetheless, we need to be familiar with them, I guess. So we have a frequency distribution table here. X is for my score, F is my frequency. So this is saying that I have 12 ones, 18 twos, 40 threes, and so on. It's going to help, I think, if we added all of those together, but hold off on that for now. Oh no, let's add them together now. 12 and 18 is 30, and 40 is 70. Is 95 and 100. So I'm going to write this little thing here. This sigma f means the sum of the frequency is equal to 100. That's helpful because, remember, it's helpful for two things. When I calculate the mean, I have to divide by the number of scores. I've got 100 scores, so I'm going to divide by 100, and how convenient. I like dividing by 100. Now, fx simply means the frequency times the score, right? So 1 times 12 is 12. 2 18s are 36, 3 40s are 120, 4 25s are 100, and 5 5s are 25. Now, if I add these together, I'll have to do that. I need a little bit more space here. The sum of the fx column. Whoops. The sum of the fx column, this one here. 12 and 36, 48, 168, 268, 288, 293. Right, and so now I can say that the mean is equal to the sum of the fx, I'm going to say, divided by the sum of the frequency. Okay, because really that's the sum of all the scores divided by the number of scores, which equals 293, I hope, divided by 100 equals 2.93. And does that make sense? Well, looking at my scores, they range between 1 and 5. There's not many 1s or 5s, so somewhere in the middle here. Yeah, that looks pretty good to me, I guess. Does it? Yeah, close to 3. Really? Yep, I think that's right. For me, 2.93 is the mean. Now, CF is for cumulative frequency. Cumulative meaning sort of continually getting bigger, accumulating, adding to it all the time. So, I start with a 12. And what I do is I add this next number on. So 36 plus 12 is 48. In fact, really what's going down in this column are the numbers that I was calling out as I was adding it up in my head, or out loud. So now 48 plus 120 is 168. Plus 100 is 268. Plus 25 is 293. So you can see that I do actually arrive at that number anyway, but it's a handy check. Okay, it's a... no, that's not what you do at all. Right. It is the sum of the frequencies, not the fx column. My apologies. We don't often use both of these columns. So it's 12 plus the 18 is 30. My apologies for the mistake there. Plus 40 is 70. Plus 25 is 95. And the 5 is 100. That's what our cumulative frequency is for. And that adds up to this 100 here. I can check them that way. Okay. I think it's worthwhile doing them separately so that you've got a backup. Okay, so there's my 100. Now, what this cumulative frequency column is helpful for is calculating the median in this case. Now, we know that the median separates the top half from the bottom half, and that we've got 100 scores. So there's 50 scores in the bottom group, and there's 50 scores in the top group. So somewhere between the 50th and the 51st score is our median. Now, where does that happen? Well, the first 12 scores are 1 or below. The first 30 scores are 2 or below. The first 70 scores are 3 or below. So somewhere within all of this list of 3s, imagine that I wrote 100 scores out here with a bunch of 1s, a bunch of 2s, a bunch of 3s, and so on. The 50th and the 51st scores would both be 3s. So the median is equal to 3. And that's a handy sort of trick there, but I'll show you soon that we can do this on the calculator anyway. Rightio, but nonetheless, see how we use a cumulative frequency column, correctly calculated, to calculate the mean. Now the mode is easily read off this thing, looking down the frequency column, and all I'm looking for is the highest frequency. That is the highest frequency. That does not mean the mode is 40, it means that the mode is 3. The mode equals 3. There we go. So that's how we use a frequency distribution table with either an FX column or a cumulative frequency column, perhaps both, to help us calculate some of those things there. But now, here's where the good stuff comes in. Let's use our calculator to do these things as well. There's some instructions there. I'm not going to talk through them. You can pause and read them, or you've got the notes. Read them there. Refer to them at times. Hopefully they're all correct. I'm pretty sure they are. Now, here we go. Use your calculator to calculate the mean, the median of each data set. Calculator doesn't give you the mode, but, you know, like here, the mode. What's the mode? 30. Here, the mode. No mode, right? All those scores are different using a calculator. So, let's pull up the calculator. Where's my hang on. Here's my calculator. Right, first thing we're going to do is reset it. So, second function, 9, 3, equals an AC. We do that to make sure there's no other data in there. There's no other weird settings that are messing with our data. It's a good habit to get into doing that a lot. Reset your calculator. Make sure there's nothing carrying over. Now we want to put it in stat mode. So mode 2, and we always choose option 1 here, certainly for the time being. Because my first data set here is a small data set, look, I could add those up. And calculate the mean that way. It's only 5 scores. I could add them together and divide it by 5. That would be fine. Also, I could rearrange them in order and calculate the median that way too, but I just want to show you on the calculator. But I don't have repeated scores, not like over here where there's many hundreds of scores. So I don't need a frequency column. I'm just going to put my scores in. 102, and I press equals to lock that in, move on to the next one. 346. 158. It's worth glancing at the screen every now and again. Make sure you're typing in the wrong thing. You haven't accidentally tapped the same button twice or something. 295 and 577. Okay, there's my scores there. It sort of shows me. Now, this number in the left-hand column is just sort of counting how many rows of data you have. So, I've got 5 rows. There's 5 scores. Right, that's good. All clear. Looks weird. I haven't deleted it, it's saved in there. That little 0 is a bit of a reminder that I'm in stat mode and there might be saved data. Now to access our stats, we go second function 1. Here, see how it says stat and VAR, whatever that means. Above the 1, the yellow button accesses the little yellow things on your calculator. Those superscripts. Now, from this menu here, I will find the mean under option 4 there. You just got to remember that. Option 4. Now, there's the mean. There's that little symbol I've been using before, X with a bar above it. So 2 equals, and my mean is 295.6. Is 295.6. Quick glance at that. Seems okay. Now I want to find the median. Come back calculator. Here it is. All clear. Second function 1. Now min max for the median. And here, med is for median, 4, and equals, and 295. How curious. The median, it's funny what I get excited about. Median equals 295. They were very randomly chosen numbers. How strange that the median and the mean in that instance happen to be very similar. Oh, not media, median. There we go. So that's using the calculator for, honestly, a small data set. Maybe that's not the most efficient way to do things. Good practice though. Now, to do the next one, as I said, there are hundreds of scores there. I don't want to type 10 in 267 times. Right, I'm going to use a frequency column. I'm going to reset the calculator again. Second function, 93 equals AC. Now I put it back into stat mode, and option 1 there. but I want to introduce a frequency column, and this is slightly more involved. Second function mode, you can see, is for setup. Now it's none of these options here. You've got to use the arrow button there to scroll down, and you've got another menu, and one of the options there is 3 for stats. Choose option 3 and 1 to turn it on, and now I have a frequency column as well. So I put my scores in. It's most efficient to put the scores in first because you've got to press equals, and that always moves you down a row, and it's just a bit annoying using the arrows to keep going across each time. If I use the arrow to go down now, it'll scroll to the top and once across, and I can do these ones: 267, 144, 587, and 21. Okay, there's my scores there. It's nice that I can review all of those scores with my arrows, go up and down, see that it all looks about right. But there we go, there's my scores, and I press all clear. Now, if I wanted to know how many scores there are, that's not often a question, but, you know, if I do that, if I go to option 4 here, now, N is for the number. It's going to tell us how many there are, so let's just have a look. What do you know? There are 1,019 scores there. Rightio. But I wasn't asked for how many scores are there. I want the mean, which is option 2 here, is 23.55, let's say. Mean is about 23.55. We'll call it 2 decimal places. And my median, now just having a quick look, what do you think the median will be? I think it's going to be a 30. Second function 1, 5, 4, equals, oh, there we go, my median, oops, equals 30. Now you see, there's not a lot of hard work in your head to do there. You've just got to know how to operate the calculator. You have to remember how to do that. You can pause and rewind, watch the video again, you know, more clicks, more likes. You have to remember how to do it, and then it's really very straightforward, right? Once you remember what buttons to press on the calculator. Anyway, now we need to move along to this stuff called grouped data, and from my former experience teaching junior students, this is something that's never picked up terribly well, and we've got to cover it pretty quickly. So we really should do an example of this too, and that will get us to the end of, whoa, look at all these things happening. Ooh, don't look at that. This will be our last example here on this monster of a video. So, sometimes what we do is we group data into intervals, and we use a class center, right, the middle of that interval, as like an approximation for all of those scores. Now, this is particularly important with continuous data, because continuous data really probably never has any two scores the same. So a mode, for example, is absolutely pointless. But yes, when we're drawing a histogram or something, it allows us to reduce the number of columns to get something more meaningful, to make it a bit easier to see trends and patterns in our data. So the class center, all we do is we add these two numbers together. 1 and 10 is 11.5, that is 5.5. And so on, 15.5, 25.5, 35.5, oops, and 45.5, right? We're going to treat all of the scores as these centers because, you know, within the group, they must all be reasonably close to that center. So we put in the class center, and then I use that as my score and that as my frequency. So back to the calculator. Where are you, calculator? Here we go. Reset second function 9, 3 equals AC. Yes. Now back to mode 2 for stats and option 1. And second function mode, arrow down, option 3 and a 1 to get scores and frequencies. Now my score here is 5.5, 15.5, 25.5, 35.5, 45.5, and now I put in the frequencies of 2, 5, 6, 18, and 3. Now, because we have essentially rounded all of our scores to the center, what a strange thing. We usually round up or down, now we're rounding to the center in a way. I've lost some detail out of my data, so this becomes an approximation of the mean. Okay, second function 1, 4, 2 equals 29.9. So my mean 29.9. All good? Rightio. Thank you for your patience. That's just clocked over the 20 minutes now. You've done very well. There is a lot of stuff in there, none of it terribly hard, but really important that you remember it all and you know how to do it. Okay, hope you loved it. I'll see you in class.